Today we're diving into Rust's primitive data types: integers, floating point numbers, Booleans, and characters. By the end of this video, you'll not only understand these types, but also why Rust is so strict about them. So buckle up, and let's get started. Before we get into specific types, let's talk about Rust's type system in general. Rust is a statically typed language, which means that every variable has a specific data type that must be known at compile time. Unlike dynamically typed languages like Python or JavaScript, where you can change a variable's type anytime, Rust forces you to stick to one type for a variable. Why does this matter? Well, by knowing types at compile time, Rust can catch potential errors before your code even runs. That's a big deal for writing safe and efficient programs. Now, let's start with the first category, integers. In Rust, integers are whole numbers without decimals. But unlike some languages that just have int, Rust gives us multiple integer types, based on size and whether they're signed or unsigned. Let's look at an example. Here, i32 means signed 32-bit integer, which means it can hold both positive and negative numbers. On the other hand, u8 is an unsigned 8-bit integer, meaning it can only store positive numbers from 0 to 255. Rust provides various integer sizes, ranging from 8-bit to 128-bit. Here is the table showing all signed and unsigned integer types with the size and range. So, when should you use signed versus unsigned? Well, if you know a value will never be negative, like an age or number of items in stock, then using an unsigned integer, u8, u16, etc., is more efficient because it gives you a larger positive range. But if you need negative numbers, go with signed integers, i8, i16, etc. But be careful, Rust strictly enforces integer sizes. If you try to store a u8 value that's greater than 255, Rust will throw an error. Alright, now let's move on to floating point numbers with decimals. Rust has two floating point types, f32, 32-bit, and f64, 64-bit. By default, Rust uses f64 because it's more precise. Here is a simple example. Here, pi is an f64, and e is an f32. The difference: f64 is more precise because it uses 64 bits to store the number, meaning fewer rounding errors. In most cases, just stick with f64 unless you really need to optimize for memory. One thing to watch out for with floating point numbers is rounding errors. Since computers can't always store decimal numbers perfectly, calculations might not be 100% accurate. This happens in all languages, not just Rust. So if you need precise decimal calculations, like for money, you might want to use Rust's decimal crate instead. Next up, we have Booleans. These are super simple, just true or false. Rust uses the bool type for Booleans. Let's see it in action. Rust's Booleans are mostly used in control flow, like if statements. We'll explore that in a later video. Last but not least, characters. Rust's character type is 4 bytes and can store any Unicode character, not just ASCII. That means emojis, non-English letters, and symbols all work fine. Pretty cool, right? Unlike some languages where characters are 1 byte, Rust uses 4 bytes, so it can handle any character in the world. And that's a wrap. We covered integers, floating point numbers, Booleans, and characters in Rust. Now I want to hear from you. What's your favorite Rust data type so far? Drop a comment below.